Our signal is away from this world, 390 light-years from us. In fact, for context, a light-year is equal to 6 trillion miles. Human observation has led to a wonderful revelation that transcends the nature of time. In a surprising surprise, the James Webb Telescope captured a stunning view of pre-stellar formation that points to something older than the universe. This discovery has great consequences, prompting scientists to quickly find the answer to this mystery. Is our understanding of the Big Bang incomplete? What forces contributed to the formation of this mysterious and 13.8 billion-year-old structure? The James Webb Space Telescope has become widely recognized as an amazing space probe that captures a global view of the stars and galaxies and brings its amazing views back to Earth. Recently revealed a mysterious sight, a 13.8 billion-year-old celestial structure that challenges the foundations of our cosmic understanding. Through this amazing technological marvel, we experience a deep mystery of the universe that weaves through space. This unexpected discovery provoked many discussions and explanations in the scientific community. Famous scientists and famous observers around the world are firing daily questions about this mystery. The most famous of these questions is, how can the James Webb Telescope find a structure 13.8 billion years old when the universe is much younger than that? To understand this mysterious structure, let's look at the details. At the far end of the universe, about 200 light-years from us, lies a famous star called HD 14283. Located 13.8 billion light-years from Earth in the constellation Libra, this giant star offers spectacular views of its turbulent past about 12 billion years ago. This star is special not because of its structure and characteristics, but because it is different in time. Imagine a time when our Milky Way was still in its infancy, absorbing a cloud of dust called home. What surprises us most about HD 14283 is its surprising age. Among the celestial bodies that we have seen, this star is one of the oldest stars that we have seen, and the affectionate name is Methuselah, which is related to the biblical character who lived for 969 years. It is estimated to be 16 billion years old. However, new calculations using NASA's Hubble Space Telescope indicate a much younger age of 14.46 billion years, with an uncertainty of 0.8 billion years. The discovery surprised astronomers, as the age of the universe from the microwave background is about 13.8 billion years. The James Webb Space Telescope is an amazing feat of human intelligence that is changing the way we explore space. The Superpower Observatory, named after James A. Webb, named after a great man in the early days of NASA, will take space exploration to a new level. Designed to detect infrared light, it can pick up faint signals from the most distant and oldest objects in the universe, providing insight into the early days of life. Before looking at how the James Webb Telescope discovered the 13.8 billion-year-old structure, let's understand how to determine the age of stars. Determining the age of celestial bodies can be problematic. For example, stars retain their brightness, temperature, and size for billions of years, which is still a challenge today. Astronomers use changes in brightness and color to indicate their age and compare these observations to patterns of how stars grow over time. One of the indicators of a star's age is its rate of rotation. Just as a wheel slows down due to friction, stars also slow down as they age. What clues does the Milky Way have about the age of this mysterious structure? Let's dive into the amazing dance unfolding in our cosmic backyard, the Milky Way. Recent measurements have revealed a surprising observation. Stars that live at the outer edges of our galaxy show slow, almost faint motions compared to their counterparts in other galaxies. The discovery sparked a wave of cosmic research, and astronomers wondered if our Milky Way was missing a hidden cosmic element known as dark matter. Unfortunately, it is a complex substance that interferes with direct observation, exerts an influence on celestial bodies, and creates a mysterious space in the atmosphere. This cosmic mystery challenges our understanding. Perhaps our global compass is wrong. Enter the Gaia satellite, the European Space Agency's star observatory, which sheds light on the intricacies of the nearly 2 billion stars in our Milky Way. Gaia is like a folk dance instructor, providing precise measurements to encourage astronomers to rethink their dance narratives. Stars outside the Milky Way travel much slower, challenging assumptions about speed. The velocities of stars can provide interesting insights into the mass of a galaxy. such as estimating the size of a population by looking at its velocity. Using detailed data from Gaia, astronomers have estimated the combined mass of the atmosphere, dust, stars, and dark matter to be 200 billion times the mass of the Sun. This mass, as measured by Gaia data, is 5 times smaller than previously thought, challenging assumptions about the abundance of dark matter. This discovery suggests a theory that there may be less food in our celestial soup than previously thought. However, the weight of the galaxy is a real challenge. Gaia data may have some features, or our measurement tape may need correction. However, many research groups are crying out in the same air. If true, this discovery would mark a new chapter in our planetary physics textbook, a revolutionary paradigm shift that will force us to rethink not only our own Milky Way, but all the bright corners of the world. The world's journey to understand dark matter began in the 1970s when astronomer Vera Rubin and her team deciphered log patterns of stars in some other galaxies. At that time, the cosmic playbook says that the stars will move out of the galaxy. As the Milky Way zooms in, we are just as challenged. For example, our Sun, which is 26,600 light-years away from the galactic center, rotates at 800,000 kilometers per hour. In 2013, the Gaia satellite was launched as the perfect satellite. Their data has given us a global symphony, improving the accuracy of time. In 2023, a number of research papers revealed a climate shock. Stars up to 100,000 moon-years from the heart of the Milky Way appear to be receding. It's as if the stars have decided to hit the spots and do a good demotion. In contrast, stars and other galaxies follow a rhythmic pattern, moving from the center to the outer edges of their galactic home. This discovery took the world by storm. An interesting fact is that we need to update our understanding of dark matter. If stars in the outer regions of the Milky Way are moving more slowly than expected, it could indicate that the distribution of dark matter is different than previously thought. This discovery opens new avenues for the study of dark matter, energy, and galactic dynamics. Astronomers analyze Gaia data, refining models, and finding new research. The cosmic dance of the Milky Way presents an illusion that challenges our understanding of the dark matter and dynamics of the galaxy. It serves as a reminder that the world is a vast and mysterious playground that invites us to explore its endless wonders. The quest to understand the world is driven by knowledge and mysteries that challenge our imaginations. Advances in astronomical technology, such as the James Webb Telescope, have opened new windows on the world, providing insights that were otherwise unavailable. By extracting information from the structures of the early universe, scientists can peer into the universe's infancy and uncover the mysteries behind its formation and evolution. For example, the cosmic microwave background, CMB, is radiation left over from the early universe that provides a wealth of information about its past. The differences between current models and new discoveries, such as the ancient structures discovered by the James Webb Telescope, indicate that we need to update our understanding. This led to a re-evaluation of planetary theories, including the rate of expansion of the universe and dark energy. In addition, advances in computer simulations have allowed astronomers to create accurate models of galaxy formation and further develop our theories. In the study of planets, instruments such as the Space Telescope's infrared sensors analyze the atmospheres of distant planets, looking for signs of life or life. This has huge implications for the search for extraterrestrial life and our understanding of planetary systems. By exploring these distant worlds, we refine our search methods and continue to try to answer deeper questions about life and our place in the universe.